The last type of survey that I want to show you how to analyze in Stata is data from a stratified cluster sample. So this is just sort of to give you a flavor of what a more complicated survey design might look like and how you would go about analyzing that data. So again, we have this broad population of Inventia, and we want to implement a stratified cluster sample. So the first thing we do is we break our population up into strata. Our strata are again going to be the 4 provinces, province 1, 2, 3, and 4. Within each of the 4 provinces, we're going to sample 5 districts. So let's take province 2, for example. This guy is going to be broken up into a bunch of different districts. And we're just going to randomly sample 5 of those districts. So this gives us a total of 20 districts included in the survey. Now, within a given district, we're going to take a random sample of 50 people. So again, we have 20 districts, we have 50 people. When you multiply those together, we get a total sample size of 1,000. So I've now shown you 4 different ways to take a sample of size 1,000 from this population, and they all use different survey designs. This is arguably the most complex. So we need to think about how are we going to define our finite population corrections and how are we going to define our survey weights. So to sort of think about it, I think the easiest logic to use is we need to think about an example. Consider a guy, Bob, who lives in District 2 of Province 2. Now, Bob's just a random guy. What's the probability that Bob gets included in our survey? So the first thing that needs to happen is District 2 has to be included in our survey. So our first stage, the fraction of the districts that are sampled within District 2 is going to be 5 out of the total number of districts in Province 2. And this is going to be the first stage finite population correction for our survey. Moving on, now that we've got District 2 in our survey, what's the probability that Bob gets included if District 2 gets included? Well, we're sampling 50 people out of District 2, so his chance of being included is 50 divided by the number of people in District 2. So now we have a finite population correction, but it's going to be province specific since we've broken our population up into provinces. So we have our stage 1 correction, and then we have also this stage 2 correction. To get our survey weights, again, we can just do FPC1 times FPC2 and invert that guy. Let's go ahead and open up our Stata data set and we'll analyze this data. I know we've worked through this really fast, and if you don't understand all of the intricacies, that's okay. Feel free to spend some time on your own working through the math, or just try to concentrate on learning more about the simpler surveys that we already analyzed, and don't fret if this seems like a lot of math. So within Stata, open up the dataset stratifiedcluster.dta. As before, the first thing we're going to do is generate our finite population corrections. Recall that we're sampling 5 districts from each of the 4 provinces. So our first stage finite population correction is going to be 5 divided by the total number of districts within a province. Now we can generate our second stage finite population correction, FPC2, and recall we're sampling 50 individuals within a district, so our second stage correction is going to be 50 divided by the district size. Now to generate our survey weights, we would say generate weight underscore strat cluster. That's the variable name I'm going to give it. And again, we do FPC1 times FPC2 and invert that guy. So our first stage finite population correction, it's going to be constant within each province, remember, because number of districts is going to be constant within a province. Our second stage finite population correction, it depends on district size. Remember, it's the number of people sampled per district. It's going to be constant within a district. Let's go ahead and survey set our data. Again, we're doing a 2-stage survey because we have 2 stages of sampling. At the first stage, our unique identifier is contained in the variable district. And we need to specify our survey weights by saying p-weight equals and the name of our weight variable. If you want to specify a finite population, we do FPC and the name of the variable. And then again, because it's a stratified cluster survey, we have to specify our strata. And in this case, our strata are the provinces. So I just put province in the parentheses. The double bars tell Stata that, okay, now we're going on to the next stage of sampling. Within a district, I sample people based on the unique identifier contained in the variable ID. And then I specify my second stage population correction, FPC2. Hit enter. And you can see I have strata defined by province. My sampling units at the first stage are districts with a finite population correction. At the second stage, my sampling units are individuals denoted by this ID variable. And we have a second stage finite population correction. Again, I can say survey proportion malaria. And I find an estimate of malaria in this case to be 15.5%. And I can get a design effect. In this case, I find that my design effect is 1.60. Now, I haven't asked you guys to think much about the standard errors in this situation or even the confidence intervals. We're going to think a little bit more about that in the interactive exercises that follow.